Hey everybody, this is Larry, this is me going Q2 of the weekly contest 447 Path Existence Queries in a Graph 1. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So there's a lot of different ways to solve this one, but probably, I don't know. But the way that I did it was with union find, right? And the core part about this problem, really, you don't really need to say. You can have just, you can think about each, let me actually bring up the drawing thing real quick. And this is kind of, I would say it's important, but it is a core part of understanding Q4, so I do want to go over it a little bit more in detail here, so that you can refer to it later. But the idea for me is that, okay, well, I mean, whether it's sorted, it actually doesn't matter too much. I mean, you have to do more work, but the idea here is that, okay, so let's say you have a number line, right? Let's say the number line was straighter, barely, and then now you have some numbers, right, represented by a point, right? So maybe you have here, 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 right? And the thing is that you don't, if you want to build out the n square graph, and that's probably part of the hard part, is that if you're not super careful, you'll build n squared graph, but n is 10 to the 5th, so that's too slow. But all you have to do after sorting, which is already sorted anyway, is look at adjacent ones, right? Because then now you have this this transitive property type thing of, okay, let's say you have A, B, and C. If A is connected to B and B is connected to C, then A is connected to C, right? And it doesn't really matter whether C and A they're close enough or not, because that's just how it works. And you could do some proofs by not contradiction, but just proofs on how maybe it is contradiction, that, you know, yeah. And then now what is a query, right? So a query just gives you like one index, one index and one index, and you just ask to see if they're connected. Well, because the way this is structured on a timeline, and that's why I like drawing this, is, let me make sure that's on the screen. The reason why I like to draw this is that this visualization does allow you to kind of well, just visualize it, right? And what I mean by that is that if A is connected to B and B is connected to C and dot dot dot, there's no way, there's no thing in which like A is like, let's say this is D, there's no thing in which A is connected to D but C is not connected to D, right? And you can see why, pretty trivially. I don't want to kind of, you know, I don't want to do the proof too hard, but you can see it. Anyway, and then as a result, then now you have a line segment that looks like this, going from the beginning of the connected piece and then the end, right? And then now, given these queries, you just have to find out if they're in the same piece. If they're in the same piece, that means that you could traverse in any number of moves to it. And if it's not, then, like, for example, maybe these is one, but then these are not, then there's just no way. And that's basically it. And of course, there are a number of ways you can think about doing this now that you have this visualization and this idea. But the way that I'm going to do it is with union find, or disjoint set union. I'm not going to go into details for this video, but that's we'll go over the code, but not necessarily the idea or the explicit details about union find, right? So all you have to know is that I do union find here. I wrote this out from scratch. I end up still writing it about like 2.5 minutes, right? So I wrote this out, and then it's just literally if adjacent, and this is always sorted, right? So if adjacent elements, you know, less than max diff, then we union them, and then once we union them, we just have to find if they're in the same piece, connect the component, and that's it. Yeah. For the purpose of this problem, I know there's some nuance. You could say that these are all of one operations amortized. So that means that this is linear, and this is linear, and this is n plus q linear, and that's it. That's all we have for this one. Let me know what you think. Thanks for watching, and you could watch me solve it live during the contest now. YOLO submit. Probably should double check some stuff, but it's fine. Okay. Sorted nums and nodes, sorted nums, max diff. Okay, so if the okay, maybe it's just a path. Okay, so it's just like it's sorted order, right? So it's just line segments and whether they're connected. This is kind of a really weird way to put this form, and also not that difficult per se. I'm trying to think whether I want to do union. Fine, let's do it. I was debating it too much. Is it one indexed or 0 indexed? I guess these are just yeah, okay. I guess I defined that. All right. Then we just union I minus 1, right? And that should be fine. Maybe the other way is a little bit more, and then queries for what am I returning? True false. If right. True false, and then false true. Alright. Hopefully no silly mistakes. Okay, good. Well, this is now fine. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about each problem, this problem. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.